Welcome to one of the most interesting topics for people who are interested in freight rail. Historically, car location and information about the status of a car has been primarily in the hands of the rail operator. But in fact, shippers find that dealing with large railroads is a very frustrating and difficult process to get information on a real-time basis and to integrate it with their own internal systems that track the movement of goods. And so a number of people have been working on this, and I've tried to gather together three of the people who are leading the charge. There are many, many people who are working on this program. For instance, RailPulse is a nationwide group of people who are trying to establish standards for this, and this is supported by Norfolk Southern, by Greenbrier, and others, but they are not providing a service directly. But I have here Trinsight, which is Trinity Rail. I have Nexxiot, which does the same thing in Europe. And I have Quasar, which operates primarily in Canada, but is looking to expand in the United States. They work together because they are using, in many cases, the same hardware, the same software, but they've each taken a different approach to the basic question. The shipper wants to know, where is my car? Now, I also am a trucker, and I've been in the trucking business off and on for the last 25 years, and gee, we just have a little transponder that we tack onto a trailer, and you ping it, and it tells you where the trailer is. Now, this is pretty simple, and this information is available on a broad scale. The railroad situation is much more complicated than that. But it does suggest that there's a way forward. So what I've asked each of the people to discuss is sort of how they are tackling it, how they're getting information out, how they're working with customers, with shippers, and how they work together with each other. So I think just in the way I wrote it down, Dan Anderson is with Trinsight, Trinity Rail, which both builds and operates one of the largest tank car fleets of various types, as well as other types of equipment. And so why don't you start, Dan, and then I'll ask Corey and I'll ask Dan McGregor to talk about your areas.
Sounds good, Carl. Thank you.
Why don't you stand there and speak there?
Sounds good. Good morning, everyone. Appreciate the opportunity. Carl, thank you for the invitation. Again, my name is Dan Anderson with Trinity Rail. I am the Vice President of Strategic Marketing and New Product Development at Trinity. Love to talk to you a little bit about our new product called Trinsight, as well as our efforts in the broader remote monitoring adventure that we're all going through in the freight rail system today. So if you wouldn't mind progressing to the next slide. For those that are not familiar with Trinity Rail, we are an industry leader in providing railcar-based supply chain solutions to shippers and to railroads in North America. With our breadth of over 700 customers across 5 distinct market segments, and our depth with 135,000 cars in our fleet and products and services across the railcar lifecycle, we're viewed as trusted industry experts delivering innovation that optimizes freight rail shippers' supply chains here in North America. We have a number of recently introduced award-winning products and services that further enhance our ability to improve customers' businesses with lower cost, greater consistency, and simplicity, most importantly. But today I want to talk specifically about our efforts in remote monitoring. So if you could progress to the next slide. This is how we're thinking about it, and I want to dwell on this side a little bit and then turn it over to Corey. This is the 3-step process, very simplistically. Many in the data analytics space would frown at my simplicity here, but for those of us that think at my level, we're thinking about it 3 steps. First, it goes down to the equipment. you actually need to generate more data off of the rail car in service. The rail car is the center of a shipper's rail supply chain. It is what moves, protects, and stores their commodity that delivers their revenue. The rail car is the center of their world, so it is what must generate the data in our mind. And that'll be up to the equipment owner. For those that don't know, only 20% of the rail cars, freight rail cars in North America today, are owned by railroads. Over 50% are owned by lessors, and roughly another 20% are owned by shippers outright. It'll be up to all of us working together to outfit those rail cars with the necessary sensors and hubs, like Nexxiot and others provide, to generate the data for all of us to use. The next step we're thinking about, we were one of the founding members of RailPulse, which is a joint venture to promote standards across the entire remote monitoring space in North America's freight rail system. You're going to need to transmit the data to the cloud, store it, standardize it, protect it before it can be delivered for use to shippers to inform their big business decisions. And the last step is the actual delivery of those data points, not just a data dump, if you will, of a bunch of data points, but a tool that can easily translate all those individual data points into actionable insights that then drive improvements in customer supply chains. I'll tell you one story, and then I'll hand it over to Corey. There are additional slides here, too, that if they get sent out, more details on both RailPulse and Trinsight, but I'll leave you with a story. Early in our adventures into remote monitoring and freight rail, we were working with a customer that was using covered hoppers to ship their freight from the western United States out to the east. And they were seeing a dramatic increase in the number of bad order events that their covered hoppers were experiencing due to damage that occurred due to high impact events in their supply chain. They were convinced that the railroads were humping their cars very heavy in yards along the way. So they asked us to outfit those cars with accelerometers and GPS units to see what was going on. And they could see exactly where the railroads were doing this. Interestingly enough, we outfitted those cars with accelerometers, and we found that the impacts were actually occurring at the customer's loading facilities, allowing them the opportunity to change their processes, work with their compatriots at the loading facility to mitigate the events that were causing the damage and save themselves $1.2 million annually, as well as improve their in-service time for their rail cars by over 13,000 hours a year, which is a big impact and a really quick ROI on a simple investment of getting more data off your rail cars. So with that, that's what we can do at Trinity Rail. That's our adventure. That's how we're approaching it. And I think, Corey, you're up next.
So I'm Corey Banks. I'm a 26-year supply chain professional. I started my career at Canadian Pacific Railway in 1996, so I'm aging myself. I left CP and went to be a shipper. And so I have a little bit of a unique perspective in that I can sit on both sides of the fence and understand the industry and what's happening. For the last 4.5 years, I've been leading Quasar platform, and our goal is to create better visibility across the supply chain within the rail supply chain network, not just at the Class 1 level. I think we do a pretty good job of actually understanding where the rail cars are when they're in possession of the Class 1. But then when we move off of the Class 1 and we go into origins, destinations, short lines, other areas, we lose visibility to where those rail cars are. And so the whole mission at Quasar is to provide visibility end-to-end, so true end-to-end, from origin or raw material all the way through to destination and return. To do that, we are cloud native. We have GPS on rail cars. We collect data from AI readers, some that we install, lots of others that we use from Class 1s. We integrate data from car location messages and industry data. And the reason that we do that is it gives us that very full picture of the rail car. We take data from emails, text messages, and other strange integrations. And the reason that we do that is because there isn't just one source of data that we need to integrate to give us that full end-to-end picture of supply chain. So we've created this world that we call our dataverse, partially because our marketing is very cheeky. A quasar is a beam of light shooting through a black hole. And we believe that right now in the rail supply chain, we've got a lot of black holes. And so Quasar's marketing somewhat cheeky in that we're looking at, closing those gaps and making sure that we can see the supply chain end to end. We believe in getting the operational data, so where is my rail car? I say, dude, where's my car? But also, what status is it in, right? So is it bad ordered? Is it at arrival, destination, in transit, set off? What's happening to that rail car and your goods that are inside that rail car? And then also, what's the financial part of this? So at Quasar, we're looking at end-to-end supply chain, almost like a supply chain ERP, where we've got operational data, we're calculating financial information, and then we pull it into our Dataverse, and we provide you a picture of what your end-to-end supply chain looks like. So yes, we use IoT. We partner with Trinity and we partner with Nexxiot in order to provide visibility. We're not all things to all people. So the other thing that we firmly believe in is collaborating with our partners, our competitors, the Class 1s, the shippers, RailLink, RailPulse. We're very open and very collaborative. And the reason that we are, I'm going to steal Daniel's phrase, sorry, Daniel, is that we believe that it takes a village. It's a team. Supply chain is a team sport. There's lots of handoffs. Hundreds of people are involved in getting shipments together. We need to be able to collaborate and connect, provide data faster. And I'll just tell a story like Daniel did. We started talking about what's happening at the origins and the destinations and why is it taking so long to get our goods to market. And we started to realize that we actually have some control over changing how things are done today. So today, somebody is expecting something to arrive on a Tuesday, and then it doesn't arrive. And so on Wednesday, the next day, they realize it didn't arrive, and they start to investigate why it didn't arrive. And by that time, they've contacted the Class 1 or their short line partner or whoever it is. And then Thursday comes and goes because we haven't had enough time to actually deal with the issue. And by Saturday, we finally get our rail cars, almost a full week later. So if we can communicate faster and we can deal with those issues more quickly, there's 4 or 5 days of cycle time right there that we're going to be able to take out of the supply chain network without having to build more infrastructure or put more rail cars out there or, beat up anybody about performance. It's just about being able to get better visibility faster and communicate together more quickly so that we can address the issues. Maybe if we had GPS on rail cars that flipped a trigger and said, hey, your cars didn't leave and they haven't actually arrived at your destination using a geofence and an alert, you have a fighting chance of getting your rail cars there on Thursday instead of on Saturday. So for us, it is about communication. It's about collaboration. We've built a bunch of tools and a whole bunch of software to be able to do that. But the message I want to give today is just technology is about collaboration, and it is about us getting better visibility to our supply chain so that we can advance, and the value proposition is generating more revenue for everyone. The shipper, the Class 1, the short line, all that kind of stuff. So that's Quasar in a nutshell.
Thank you, Corey. Thank you. Hello, everybody. My name is Daniel McGregor. I'm actually from Manchester in the UK. I moved to Switzerland, to Zurich in 2002, and I'm the co-founder of Nexxiot. I founded Nexxiot in 2015, and I'm what you call a tech entrepreneur who has values. I'm not chasing the money. I want to make a big impact with my life, and I felt that the technology wasn't being applied to the supply chain maybe as it could be. And I say supply chain, I'm looking at integrated solutions for the whole supply chain. But a question occurred to me. I don't want to repeat what these two have said because they've set the scene very nicely. But a question occurred to me back then when I was saying, what can I do to make a big impact? And it was, if you can track your pet in the garden, your child on the way to school, your luggage in the airport, your new shoes through the mail from Amazon, and your pizza to the front door in extreme granularity. Why is it that you can't track and monitor a huge metal box across the planet that contain something valuable. It just doesn't make sense. We've had GPS for 35 years. We've all had mobile phones and smartphones now for ages. It's been transformational. And actually, when you think about the development of the internet, Silicon Valley was established on building hardware. So they made PCs that they sold to every university and school and business across the world, and then they sold Microsoft Windows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 until people got bored of it and switched to iOS. And you know, we've basically seen this whole technology emerge in the public space, but we haven't seen the same thing emerge in the supply chain. So what does Nexxiot do? We provide industrial IoT connectivity. It's about quality data. So this is what we call the Globe Hopper 3, which is zero maintenance, energy harvesting, ultra low power, open architecture IoT device or hub. And we developed this. This is actually the Globe Hopper 3, so we've had now 3 iterations. This is the Globe Hopper Edge, which is more focused on shipping containers. But this already, we have 200,000 of these deployed across rail, mostly in Europe, but also now in the USA. This sends every 5 minutes to the cloud all kinds of data. So we have impact, we have gyroscopes, we have accelerometers, we have a whole bunch of sensors integrated in. But also we believe in an open architecture, just like Corey and Dan said. We need to be integrated, collaborative to drive this change across the industry for the benefit of every stakeholder in the value network. I don't really think of supply chains anymore. I'm thinking more that we actually have a global value network. And what is value? Value is about transforming our lives and our experience, sure, but it's about making the most out of our resources and about enabling services for every stakeholder through that network. So why do we do it? We do it for trust, we do it for security, we do it for efficiency, and we're digitizing assets. That's the first step. We have to get high quality data. It's no good to aggregate data from port turn-in, turn-out times from some of the terminals or maybe historical data. We can't assume that the past is the key to the future. With complex systems, they're intrinsically dynamic. We've just seen the supply chain be rocked by all kinds of events in the last few years. You know, including the pandemic, including vessels burning at sea. We've got issues at the ports in Los Angeles. We saw recently all of the tracks in Los Angeles strewn with cargo debris. People have been breaking into those rail cars. And I think one of the issues is that we all jump to conclusions regarding causality. What's causing something? Maybe we tend to refer to our own biases and we look at what we know, but actually it's often what you don't know. And with big data, you can start to dive into the truth and you can discover things that maybe are really causing things. So, you know, with the example of just to add to the stories here, with the example of the recent thefts on the tracks in LA, everybody says, oh, it's a lack of security, or they've defunded the police, but actually, if you look at a huge rail composition, and you try to defend that from thefts if it's stationary, it's very challenging because you need to have a lot of security, you need to have a lot of technology. Actually, it's much better to keep that rail cargo flowing and then it doesn't get broken into. It's harder to break into a rail car that's moving. So that's my little intro, and now I think we're going to move into the panel discussion, so I'll stand aside.
Good. Well, I think that this has been very illuminating and has given you an idea of the challenges that the industry faces. And I just jotted down a few things to get the dialogue started, and then we hope there will be participation from the audience. Basic question, where and how do shippers get car location information now? That's kind of a basic question. Do they have independent access to location and status information? Do shippers see, and this is a key point, do shippers see a quantifiable benefit in dollar terms for this information? Are they willing to pay for that location information? Or would a Class 1 or a short line be willing to pay for the location information? I guess another basic question is, what's the business model? Is it pay-per-view? Is it a subscription? Is it an annual flat fee? How do the people who provide this key information about the supply chain be compensated for the investment they have to make? And of course, the shipper wants to know what he's going to have to put up to have this service in capital terms, and the providers, I have 3 of them here, they have to make enormous investments in hardware and software and their database to come up with accurate information that's usable. And then, of course, we get to the really tough ones, which Corey touched on. How on earth do we keep track of industrial switching operations, short lines, regionals, and the shipper themselves? I think a very interesting example that actually the shipper was causing the damage to themselves. And then, of course, another fundamental question is, how does the shipper access the data? Can it be integrated with whatever system they use to track the movement of their goods? And I think these are really interesting questions, and perhaps each of you would comment on that. And then we'll ask people in the audience who may be shippers, or they may be regulators, or they may be Class 1s or whatever. Let them respond or ask questions too. So why don't we just go in the order we started? Dan, why don't you start, and then I'm going to sit down.
There's a lot of questions, Carl, and I did not have a pen to write them all down, so I'm going to do my best to get to as many as I can and leave some for Corey and Daniel too. There's a few I'm going to leave for Corey for sure, and there's a few that Daniel will be better positioned to answer. But we did, last year when we were starting to build the Trinsight tool, we did over 350 individual interview sessions with some of our shipper customers to understand how, to answer some of your most basic questions, how do they get this data today? And how do they manage their rail supply chains and their rail car fleets with what's available in the market today? And, you know, one customer stands out to me specifically who spends 3 hours every morning going and logging in to each Class 1's visibility tool, downloading the data, copying and pasting it over to one consolidated spreadsheet, and then spends the rest of the day analyzing it. When we came in with the Trinsight tool, we said, we've already mapped all of the APIs, which are very unique, very different, subtly different across those Class 1 railroads, so you can't just set it up quick and easy and get all the inflow of data. We've taken the time and effort to do that in Trinsight, and now it's going to take you 15 minutes in the morning to do what it usually took you 3 hours to do. And that was a monumental shift. But to talk about the ROI just briefly, what we're talking about here is transformative in nature, because what you'll find is when we're talking to customers, it takes one specific use case to build the ROI that they end up taking to their leadership to justify the initial investment. But what they quickly find is as you're solving the first problem, you now have rich data about your supply chain that enlightens you to 5 other potential efficiency gains that will then justify the next round of investment. And to speak about how how the business model is working today, because we're a leasing company and we own 135,000 cars, but we're responsible for investing in the hardware that goes on the rail car. We're responsible to the regulatory bodies as to where the sensor is adhered, making sure it doesn't get in the way of the safe operation of the rail car, etc. So we're the ones that are investing in the hardware, and then we charge it back to the customer, shipper customer most often, in the form of a monthly subscription that can either be turned on or off. Because honestly, as a railcar owner, we benefit from having that fidelity about where our car is as well, whether it's speeding its time through shop, which means less rental abatement for us, more revenue for us as a lessor, and more in-service time for the customer, or whether it's out of service in storage and we're trying to get it back to a new lessee. There's benefits to us, so we're good making the investment and then charging it back based on a subscription basis to the customer at varying levels based upon how much data they want to have. So that's the first stab at a number of your questions, Carl. I think I'll turn it over to Corey now to take the next round, and if we miss any, well, maybe we'll come back up and we'll just keep hitting it until we get them all.
Sounds good. Thanks, Daniel. So to answer your question about where you get the data, as Daniel said, you get it from car location messages, AI wayside readers, and a number of other locations. A lot of pen and paper, a lot of driving around yards. So I forgot to mention that Quasar is actually a wholly owned subsidiary of Can-Do Rail and Terminals, a Canadian short line and first and last mile rail operator. So our focus has been on getting the data at origin and destination, as well as in between. But to go back to where do you get the data, right now you're getting the data manually, and then you're consolidating it into spreadsheets that only last for the day, the week, or the month that you're using it. When you're pulling data into the cloud, that is part of the value proposition. You know, when you look at taking all that data from all of those different sources, putting it in one unified place and doing it as quickly as you can. So more real time. I won't say it's to the second yet, but I think technology will advance to the point where we're streaming location of information. Take all that data, put it into one place, and then you do something with it. So to Daniel and Daniel's point, it's not just about collection of information, it's also then doing something with it. So the business model for Quasar is proving that having better data is going to actually help you optimize your supply chain and make it more efficient. So how we do that is we have in-depth conversations with the customer. To Daniel's point, you have one use case or several use cases where you can identify a high demurrage opportunity, or you can identify an extra switching, or an opportunity to reduce your cycle time. And then we charge back, same as Daniel, we buy the sensors. We've actually integrated 5 different GPS location sensors, some satellite, some cellular, and done that because our customers have asked us to. And not all sensors can provide the use case that we have. We have a unit train customer that tracks their unit train every 10 minutes through a very high mountainous corridor, very, very difficult terrain, so we have to use satellite. We have other customers where cellular is good enough, and being able to use cellular across North America will give us the data that we want. So in answering the question about what's the value that you create, it is about taking all of that information, automating it. So in some cases, inbound train lineup into a yard is actually coming from a Class 1 email that says, here's all the rail cars and the sequence of the car that they're coming in, and that's the best source of data that we have. So we integrate that email like it's an inbound train lineup and pull it in. The value there, though, is now you've got this universe of information and you know exactly where your rail car is at all times, and then you can actually react faster, as I said earlier. So the business proposition, most of our customers, we've grown our business with most of our customers between 30 and 40%. So we start out with initial baseline, and because of what we're doing, we're actually generating revenue 30 to 40% higher because of the value that we're creating for those customers. The return on investment and the value is, 4 to 24 times, depending on the use case. So there's a big return on your investment from investing in cloud-based digital technologies that provide you better visibility. Did I answer your questions? Did I miss anything? Okay, thank you.
This is pretty cool, isn't it? We're going thick and fast. So, okay, so I'm just going to make a few points about some of our customers' priorities. One of our major customers is actually a German operator called VTG, and they've got 75,000 assets, and they're actually more of a leaser. And they actually said, when we first started speaking to them, they said, no, we've looked at this, we're not going to do it. And we said, well, take a look now at the latest, what it can do. First of all, on the hardware side, it was a battery problem. If the battery was running out after, few months, most of the cost of installing this device is taking the asset out of operations and putting this hardware on. So it's a big investment. We recognize that. There's a hardware investment. The way that we actually address the business model is we decided to cover the CapEx and to integrate this hardware into the solution. So it's like hardware-enabled software as a service. And by doing that, we lowered the entry barrier significantly, and we made it possible for our clients to start to access the data. Now, with big data, you don't know what you don't yet know. Now, it sounds really obvious, but actually you start digging and you start seeing things all over the place that you maybe suspected but could never prove. So in terms of the business cases or the use cases, the first one is maintenance, to know where your asset is. And obviously we're talking about location, but location is just a single function of many use cases. You need to know the location, but you also need to know other things about the asset and how it's behaving or what's happened to it, how it's being used, or how it's being treated by third parties. So maintenance, and then it's utilization. So it's like, are we getting the most out of our fleet? Can we do more with less? Can we deploy these assets better? And we even start to look into the direction of product lifecycle management, but maybe we'll leave that for now. Next thing is services. Every different stakeholder through the value network needs a different piece of this data. So when you think about interacting with the third parties that railcar is going to visit along the way, it goes into ports and terminals. The asset is integrated with customs and with all kinds of different users. Also, if you think about multimodality and you think about combining transport methodologies through the supply chain, you know, rail is great at doing the long distances. It's about 7 times more efficient than road. But actually, why does road get so much traction against rail at the moment? It's often because it's more predictable, it's more visible. And we use this word visible all the time, but my visibility might be different from someone else's visibility. If I'm having 5-minute resolution and they have, you know, data points from maybe 2 to 3 days ago, that might mean visibility for them, but it doesn't mean visibility for me. So we're collecting shock data, we're collecting movement data, we're monitoring routing, we're monitoring third-party actions. And I'd just like to quickly build on the story that Dan Anderson said about the impact event there. We had a similar case, so we actually borrowed some of our clients' rail cars and we covered it in sensors and we smashed it up for 3 weeks. So we derailed it and we hit it with things and we dropped things on it. I can tell you there was no shortage of volunteers for this project. So what we discovered from this experience is that we actually started to understand through analyzing the big data the causality of different types of events. So actually dropping something from a crane is very different from an overzealous shunting event. And what we were able to do is identify the causality from the shock curve. So we take the shock curve to the cloud, we do pattern recognition on it, and then we can tell you exactly what caused that event. Now, this is a game changer because all of a sudden, you have the causality, you can automate the process. You can train the crane driver. You can renegotiate your service level agreement with the marshalling yard. Or you can actually send that data to the insurance team, or you can make a pre-trip inspection before you release the asset to make sure that the cargo's intact. Okay, I'm going to roll off now because otherwise I'm going to talk forever. So it's back to you, Dan.
Well, I think that's really gives you an excellent idea. Oh, yes. I'm supposed to use the mic. I'm used to speaking without one. But the issues that they have raised and addressed are, I think, critical for the survival of the railroad industry. After all, volume trends have not favored the railroad industry over the last decade. And it is the ability to get our arms around what the shipper wants that, to me, is critical. So now, there are many of you in the audience have experience and questions. Please raise your hand and ask a question or two, because we have here 3 of the best and brightest people who are working on this problem, and you've already heard some pretty extraordinary things from them.
Michael Sussman, Strategic Rail Finance. There are many innovations in rail technology that have been developed outside the United States, and it's often that it's challenging for those in the U.S. rail industry to imagine that such intelligence could come outside our shores. So I'm particularly curious of you, Daniel. What are you, without offending any of your potential clients in the United States, what is your experience of the attitude toward technology and innovation that you're seeing here?
Okay, so let's just get a little perspective on this. The USA is global leader in technology. Let's just put that down as a benchmark, okay? And there's a huge appetite for innovation in the USA. Switzerland, I'm based in Switzerland, and Switzerland has an unbelievable rail system. They also have unbelievable budgets. So, I think innovation comes from everywhere, and we're actually integrated. We have an integrated mindset, and I put it back to the introductions from these two here, because we're working together on this, and RailPulse is an incredible initiative. RailPulse is driving this initiative, and it might be that it's coming a bit later. I mean, it's already started in Europe, but it might be coming a bit later. But Europe is very different. Yeah, we have lots of different nationalities with different railway undertakings, and we have a different legacy in terms of rail. But also, we have an appetite for technology here in the US, and that's why I started with this, idea of consumer products and the way that we live our lives as consumers. We expect to be able to see, the quality and the times and the arrival and all of these details in our daily lives. So why not in rail? And I put it as an indication of there is an appetite, and we are in an incredible moment for the industry, because rail. The US was built on rail. It was actually the foundation of growth here, and it can be again. I think healthy rails mean healthy economy, and that's why we have to drive this adoption of technology. And I implore you all to get on board and to encourage this process.
Let me just add something right quick from the U.S. perspective. I met Daniel probably, how long did we figure it out?
2017.
2017, so quite a while ago, when we were still nascent in this whole endeavor. And I will tell you, I think our greatest handicap has been our greatest advantage up until this point, which is the car location messaging system. In the United States, you have CLM data that is available, that is, from many people, quote unquote, good enough. And so we haven't felt the urgency that Europe has without any location data to update our systems. But now, seeing all the use cases that they're bringing over across the Atlantic, we're beginning to see that maybe CLM is not good enough, and that's what's going to take to really drive the same level of adoption that you've seen in Europe, is showing that just knowing the location on CLM is not good enough in today's demanding environment. I'll end it with this. With one customer that we've been prototyping with, we were able to improve upon the RailLink provided ETAs by 69%. And that's just one indicator, and Corey has some great data on how inaccurate CLM can truly be when it is available, excluding short lines, Mexico, and other black holes that exist in the CLM system today.
Yes, sir.
Thank you. I think, is this on?
Yes.
Yeah. Okay, Andrew Young from On Track North America. I think one of the most exciting things that this technology brings is really the market. The market for using rail freight at the moment is really limited by the constraints of using rail. So I think for shippers and the business case that you're all talking about, the opportunity for shippers is actually a much bigger market. So rail at the moment has its limitations. We've talked about what all those are, and you're right. This technology could give more information about the equipment, improve the cycle times, but what about the huge, enormous, untapped market? Rail is 7 to 10, 11 times more commercially economical than using road, but it's not used. It's 10% of the freight market in North America. So I think this is an opportunity to open the eyes to the real market opportunity for rail in North America.
I'll take this one. I'll start. Couldn't agree more. So all of us in here are here because we love rail, and we should have a tremendous amount of pride when we talk to our friends and neighbors and families about being in rail. I know a lot of people, when I say on rail, they're like, oh, do we still use those to move stuff? And I'm like, yes, we most certainly do. And it's just frustrating, right? We're safer, we have fewer fatalities and fewer injuries per ton mile moved. We're more efficient. We move 1 ton of freight 480 miles on 1 gallon of fuel. And we've invested over $750 billion, private dollars, into a network, relieving the taxpayers of that burden over the last 40 years. And we're more sustainable. In the industrial side of greenhouse gas emissions, freight rail emits only 0.6% of all GHG from the industrial side of the economy, but we move 26% of the ton miles out there. This is a great mode of transportation, and this is just one way to overcome the challenges that prevent a lot of shippers from using it more frequently. Just to point to one use case, backhauls, empty moves, are one of the things that make rail less efficient than other modes. You can't necessarily fill a rail car with every shipper with an empty haul move back to its origination point. But with having more fidelity, you're enabling shippers to identify triangulations where they can cut down on empty miles by filling a load that may not have been possible in the past when you didn't have that amount of data to know exactly where the car is, a better idea of when it'll arrive, so that you can plan a more advanced, more multi-point, multi-origin, multi-destination supply chain around it. So,
Thanks, Daniel. And I know we're out of time, so I'll be quick. So I'll tell a story about one of the customers that we work with. They are a unit train shipper, very high velocity supply chain, as I mentioned. They've actually increased their rail fleet and their unit trains by 3. So they're shipping 3 more unit trains every 5 days than they were prior to installing technology on the rail cars. And the reason why is they connected all the parts of their supply chain. They connected the port, they connected the mine, they connected the Class 1 all together, and then they shared that data across all the parties through Quasar and through a number of their own systems, and that enabled them to actually improve their fluidity. And that's what I call a win-win-win. There's a win for the shipper who's increased their fluidity in getting their goods to market. There's a win for the Class 1 because they're actually generating more revenue because they're shipping more product. And there's efficiency gains, so your profitability has gone up on both sides. So when you talk about opportunities for rail, it is a win-win-win opportunity for us because of the efficiency gains that we can get from having better technology and better visibility.
Well, I want to thank all of the panelists for a really enlightening presentation, and I want to tease your imagination with what is possible if railroads can become more responsive to the customer and regain market share. We know we have an advantage in ESG terms. What we have to do is provide the customer what he wants, which is service. Thank you all.